There's another operator used in C. It's a weird one. It's not a symbol, it's actually a word. It's the word size of. We actually briefly looked at size of in an earlier module. Do you remember it? The interesting thing about size of is that the result that it comes up with at the time that the program is compiled, not at the time the program is run. In other words, if you've got two variables, x and y, and you add them together, it determines that result when the program is running. Size of determines its result when the program is compiling. Anyway, let me tell you exactly what size of does. It determines the size in bytes of a variable, or even of a type. In other words, if you've got an integer, it will tell you how many bytes an integer is taking up in memory. Now, you might think, well, that's pretty straightforward. Obviously, we know how many bytes it's going to be. It's going to be 4, or in other words, 2 if it's a 16-bit machine. So you think, what's the point of having a size of operator? Well, I'll show you some examples and you might see. You might have an array. How big is the array? Well, you might not want to do the multiplication in your head. Let's say you've got an array of 320 doubles. Now, a double is 8 bytes, and there's 320 of them. So, can you quickly tell me how many is 8 times 320? No? Alright, well, size of can tell you that. It'll tell you the size of the entire array, if necessary. Or, you could find out the size of just one element of the array. Now, that, of course, is always going to be the same size, no matter which element you talk about. You can even find out the size of a type. You can just say the size of float. But it's somewhat special. If you use that particular notation, if you're trying to find out not the size of a variable, but the size of a type of variable, then you must use brackets to surround the type name. Why that is, well, it's a compiler issue, and you'll think, if you think about it, you'll see why that might be. Anyway, let's go and have a look at some examples of the size of operator. This is sizeof.c in the Chapter 8 folder. Interesting name. It's a pretty simple program. It just has a bunch of printfs. I've got some variables here. I'm not even going to initialize those variables. I'm not going to put any values in them. I'm just going to print out their sizes, which stay the same no matter what is in them, of course. So the size of an integer, x, is size of x. Pretty straightforward. And then the size of an array of 20 shorts, then the size of one short. Now that 0 there, I could replace that with a 1 or a 2, or even, if I really wanted to, 200,000. Even though there aren't 200,000 elements in the array, I know that looks a bit weird, but it still would compile and it would run, believe it or not. And so on. Size of a double, size of a string of 51 characters, the size of one of those elements, one of those characters in the string, and now finally the size of a type, size of long. Notice I put the brackets around the word long, where I didn't put brackets around any of those other things. And this is pretty much compile it and run it and have a look at the answers. So let's do that. Compiles, run. The size of x, which was an integer, I'll just move this so that we can see what we're looking at here. 4 bytes. An integer is 4 bytes on my computer. It may be different on yours. However, 20 shorts is going to be 40 bytes because 1 short is 2 bytes. The size of a double is always 8 bytes. 51 chars in a string is always 51 bytes. 1 char is 1 byte, and a long in this case is going to be 4 bytes. You think, alright, that's pretty straightforward, not very exciting stuff at all. How could the size of operator possibly be useful? So, it is useful from time to time, and I'll show you a really classic example of where the size of operator can come in very handy. I'll show that to you in size of 2.c. Here's the guts of it. I have an array of a bunch of integers. Notice I have not sized the array. So I don't know how many integers there are. I just started typing in a bunch of random numbers. Now I'm not going to count them. You can count them if you want to, but imagine if there were several pages of them. You probably wouldn't want to count them then. Now I'm not going to count them. I'm going to let the program count them for me. I wonder how it's going to do that. Also, I'm going to add them all up, and then I'm going to find the average of them. Now, in order to add them up and find the average of them, I need to know how many there are. don't I? I can't do the average without knowing how many there are. And in order to add them up, I essentially have to walk along the array until I've reached them all. But when do I stop walking along the array? If I do that, plus that, plus that, plus that, plus that, plus that, when do I stop? Obviously you say, well, I stop when I get to there. Well, okay, how do you code that? You could say, well, stop when you get to 98. But I'd like to make the code a little bit more flexible than that. I'd like somebody else to be able to come in here tomorrow and add another number, 53, and have the whole program still work. Can you see what I'm getting at? So how do I know when to stop? Well, obviously I have to work out how many there are. Okay, so let's see if we can do that. Firstly, I'm going to have to write that for loop. The for loop is going to add them all up. For I equals 0. Okay, so we're obviously going to need a variable called I. Int I. Thank you. For I equals 0. I is less than what? I'll come back to that. I plus plus. There's a little plus plus operator again. And I simply want to do total plus equals. And there's that plus equals again. So I simply want to add into whatever was in total before. In total, I'm initializing to 0. Always do that kind of thing with totals. And this will be simply array I. I want to add the value of the ith element of the array into total. So here's the tricky part. What do I put here? I really need to know here how many elements of the array there are. So I'll do it like this. I'll do size of array divided by the size of one element of the array. Now I could just put, if I wanted to, int there. I could do that. However, I like my program to be a little bit more flexible. I'd like it to, even if someone came in tomorrow and changed my program, and so sorry, that's not how you spell short, and changed it to that, I'd like my program still to work without changing anything else. So obviously it wouldn't work then. So I'll put it back, and I'll go down, and I won't have this as size of int, I'll have this as size of array 0. In other words, the size of one element of the array. No matter what this is an array of, it's going to be that. It's going to be the size of one element of the array. So the size of the entire array. Let's say there were 50 things. 50 things in my array. It's clearly not, but let's pretend there were. And they're integers, so each one of them is going to be 4. So the size of the entire array is going to be 4 times 50, which is 200. 200 divided by 4 is 50. So can you see then that this entire expression would evaluate, no matter what the array was of, and no matter how big the array was, it's going to evaluate to the number of elements in the array. Now isn't that handy? Isn't that very, very handy? You can use that technique anywhere in C for arrays, finding out how many elements there are in an array. It's a great thing to be able to do. So then we can say the total is that, and the average is, well, what's the average? Let's work out the average. Average equals the total divided by the number of elements. So that's obviously this. Copy and paste. Now, got to make sure the brackets are right here, because I could divide by the size of the array, and then I could divide again by the size of one element of the array, and I don't want to do that, so I'll put brackets around that to make sure that that works. If you don't know why I just put those brackets around, have a bit of a think about what would happen if I didn't have the brackets there, and compare it. Well, actually, just run the program. Take the brackets out. Go and find the file on the CD, take the brackets out, and see if you get a different answer, because you will. Okay. So I guess we should go and compile it and see if it works. Compile, no errors, and run. Okay, we've got a total of 3001 and an average of 142. Now, I could go through and add those all up by hand. There's a 778 in there. Whoops. Hang on. Back again. 778, 111. There's a 278. So, yeah, it's going to add up at least to a couple of thousand, maybe 3,000. So we're in the right ballpark. And the average is going to be somewhere in that range. Yeah, it's going to be 100 and something, I'm guessing. Now, I could get a calculator and work it out myself. I don't even know how many numbers there are. But you see that size of enables me not to have to know how many there are. It will just work anyway. That's a really beautiful classic example of size of.